Chapter 4.2 is all about patterns and linear functions. This one does have two parts, but by the end you should be able to model functions using graphs, tables, and equations, and match a function rule to its graph or table. All right, we're not going to spend a ton of time on this one, but this is just to show you in pictures what we're going to talk about in math today. They want you to look at this picture and look for quantities in the picture that vary in response to other quantities. Okay, so things that would change because of something else in this picture. So, for example, the number of people out and about in this picture depends maybe on this temperature, what the temperature is outside, or maybe even what time it is. If it's the middle of the day, maybe more people will be in work. If it's evening, maybe more people will be out working or out walking. Also, the temperature kind of depends on the time. If you think about during the day, it's usually cooler in the morning, and then because the sun comes up, it gets warmer in the afternoon, and then it cools down again. So just take a couple seconds, look at some relationships that depend on each other in this picture, and then we can switch to the next slide. All right, vocab words for today are dependent variable and independent variable. The dependent variable changes in response to another variable. So this one depends on something else. That is your output, and it's also everything that gets graphed on the y-axis. Independent is the one that controls that dependent variable. Those are your inputs, what you plug in, and those are your x's or your x-axis items. Okay, this little funny picture here is what we call a function machine. And you put something in. Okay, so on this box is your function. So I'm going to just make one up, 3x minus 1. Okay, and this is your input, which is your x's input. So we can put in whatever we want to put in. And then whatever we put in changes this, and we get an output or a y. Okay, so say I input a 2. That means I'm going to have 3 times 2 minus 1, and my output then is going to be 5. Okay, we get to choose this input. That's independent. The output depends what I put in there for x. Okay, so the x is what we get to choose. The y depends on what x is. Independent and dependent. All right, this is just a little bit deeper definitions. If you want to write these down, or if these make more sense to you, you can pause it here and write these down. But we've got input and output as your dependent and independent, and that the dependent depends on the independent. All right, problem 1. We're going to represent a geometric relationship. So they give us a diagram, and they're wondering what is the relationship between the number of rectangles and the perimeter of the figure that they form. Okay, they want us to do 3 things. They want us to use a table, write it with words, and 4 things. Make an equation and then graph it. Okay, so first of all, we're talking about number of rectangles and perimeter. So let's look at the first rectangle and see what the perimeter of it is. Okay, we know that this side would also have to be 6, and this would be 1. So if I add up all the sides, I get 14. Okay, if I have 2 rectangles next together, now this side doesn't do anything for us anymore. So I would add up all the sides, and I would get 16. Okay, 3 rectangles all put together, I would add up and get a perimeter of 18. 4 rectangles added together would give me a perimeter of 20. Okay, so what is the independent variable? Well, our perimeter is dependent because we can't figure out our perimeter unless we know how many rectangles there are. So that means that our independent is the number of rectangles. Our dependent is the perimeter of the figure. Okay, now let's do all of those representations that they just talked about. Okay, so we're going to put them into a table first. And my x's, since we said the number of rectangles is my x, because that's my independent. and the perimeter is my y, we're going to say the number of rectangles were 1, 2, 3, and 4. Okay. If I only have one rectangle, my perimeter was 14. 2 rectangles, it was 16. 3 rectangles, it was 18. And 4 rectangles, it was 20. Okay, so there's our table. First step. Then we have to write it in words. Okay, so we know that for each additional rectangle, the perimeter, what happens to the perimeter? The perimeter, does it get bigger? Does it get smaller? Is it the same every time? To me, it looks like each time we add a rectangle, we're actually getting bigger by 2 units. Okay, so that's what we're going to put in our words. For each additional rectangle, the perimeter increases by 2. Perfect. Okay, now they want an equation. All right, well, that means we have to write down what's happening. All of it is going to equal y, equal our perimeter. But how could I figure out my perimeter for any number of rectangles using an equation? All right, so I should have a variable in there somewhere, and we'll just have to figure out where it goes and what we have to do to it. So I always use my table to figure that out. This number, change colors here. This number is a really good hint that usually goes with your variable. Okay, so if I wrote y equals 2 times x, okay, so 2 times the number of rectangles, what would I have to do to get it to where I need it? Because does 2 times x work? If I plug in a 1 and I did 2 times 1, do I get 14? No. Okay, but I know that the 2 has to go here. So what else can I do to this 2x to get myself up to 14? Okay, well, 2 times 1 is 2, so I could multiply by 7. Or 2 times 1 is 2, and I need to get to 14, so I could add 12. These are both options, but we have to make sure that it works for all 4 of these situations. So if I take a 2, and I plug in a 2 here, 2 times 2 is 4, times 7 is 28. That doesn't get me what I'm looking for, so that won't work. Let's try the second option. 2 times 2 is 4, plus 12 does give me 16. Right, try 3. 2 times 3 is 6, plus 12 does give me 18. Try 4. 2 times 4 is 8, plus 12 does give me 20. So this is our equation. I'm going to write that back here on the slide we wanted. 2x plus 12 gives me my y, my perimeter. All right, and the last thing they want you to do is to graph that. So all you're going to do is you're going to use your table that we had. Looked like this. And you're going to make a table. Your x-axis just needs the 1, 2, 3, 4. We need to get up to 20 on this side. Okay, I'm counting by 2's over here. Okay, so 1, 14, 2, 4, 6, 8, 10, 12, 14. Oops. 2, 16, 3, 18, and 4, 20. It should, because the same thing is happening every time, it should make a straight line. That's the linear part. Okay, example number 2. What is the relationship between the number of triangles and the perimeter? Same idea, only this time with triangles. And we're going to do all 4 models again. Okay, first triangle has a perimeter of 10. 2 triangles is 14. 3 triangles is 18. and 4 triangles is 22 if we add up all the sides. Okay, so let's start with our table. We had 1, 2, 3, and 4, 10, 14, 18, and 22. Okay, now before we write the words, we have to figure out what's happening. How is it changing each time that I add another triangle? It looks like our perimeter is growing by 4. So for words, I would say for each additional triangle, the perimeter increases by 4. Okay, then we're going to use this table to graph it, and we're even going to write an equation. The graph might be easiest. I only need to get to 4, so here's 1, 2, 3, 4. But up on the y's, I need to get to 22. That would be way up here if we count by 2's. 14, 16, 18. So the first triangle's perimeter was 14. Second triangle's perimeter was 18. Third, the first one was actually 10, wasn't it? There we go. There's our straight line. Okay, now the equation. Remember that we said it's changing by 4. So we know that that's what's going to go with our variable. So we have y equals 4x. Now what else do I need to do to that so that it works out? If I plug a 1 in here, 4 times 1 is only 4, but I need it to be 10. So I would have to add 6. Let's see if that works. 2 times 4 is 24. I'm sorry. 2 times 4 is 8, plus 6 is the 14 that we need. Perfect. 3 times 4 is 12, plus 6 gets us our 18. 4 times 4 is 16, plus 6 gets us our 22. So that is our equation. All right, and last but not least, last two vocab words that we're actually going to use tomorrow, but this will help. A function is a relationship that pairs each input value with only one output value. And a linear function, if you notice, it has the word line in it, so sometimes I like to write it like this. A linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So it's a straight line, but it can't be vertical. All right, this is